hands spread out. Let's start. Yeah. Good afternoon, everyone. I'm really honored to welcome you all here. We are going to discuss the cybersecurity in the nuclear infrastructure. We have here our colleagues. I'm along with Jonathan. So you can introduce maybe to move later.
So thank you, Mansour. So my name is Jonathan Vuillaume. I'm a cybersecurity engineer at Egis. And we also do have a partnership with Airbus Protect. So I let Nathan introduce himself.
Hello, everybody. So I've come all the way from sunny England. I'm a senior OT security consultant for Airbus Protect. We're a completely different division of Airbus. We do sustainability, safety, and most importantly, cybersecurity. This presentation is about cybersecurity strategies. We at Airbus Protect have done a lot of work with the nuclear sector in the UK, and we're branching out with Egis to do a little bit more work. So back over to Mansour.
Thank you. Thank you. So my name is Mansour Al-Anshira. So I'm a technical director for the reactor service line in Aegis. I'm going to make the small introduction on this cybersecurity in the nuclear infrastructure side. So before going to that, just a small introduction on Aegis. We are around 22,000 people around the world. And we have, let's say, in different continent regions. That's American and Europe and France, Middle East, South Asia. And then Asia Pacific. That's we are doing, let's say, the most of the business at the moment is 74%, more than 70% is outside France. So that's the trend in 2024. So it's showing that we are the, let's say, in the worldwide engineering company. If we come to the cybersecurity, let's talk about our old age, the previous life, the nuclear. So we talk about always the concrete as a protections for the nuclear power plants. And nowadays, as you can see that we are moving outside to the steel concrete, to the coding. So the digital side is moving, increasing quite a lot. So the next containment barrier is not made even with the, let's say, the concrete. It will be really, we have to consider the same way as the coding and to the all the digital aspects. When we are talking about the cybersecurity, we have to talk about also the security. Let's little bit park here. The cybersecurity and the security elements is starting the entire nuclear life cycle. So it's starting from the feasibility study, siting, till the decommissioning activity. So we have to consider the complete the nuclear power plant or nuclear facility infrastructure, that the full life cycle, we have to consider the cybersecurity elements. The cybersecurity is not driven, let's say, as a silo business. So it is integrated with the cybersecurity and then the physical security. So nuclear security, we protect the physical elements, and the cybersecurity, we protect the digital assets. So what we have to really to consider now, the digital vulnerability are the new access points for the cyber attacks. So that's what is showing in the last decades around the world, different infrastructure attacked by the, let's say, the cyber attack has happened to the, let's say, the different, the physical points. So that's what we have to consider when we talk about the nuclear cybersecurity elements. When we talk about also the nuclear, we talk about the safety. So now here, what we need to really to differentiate and to understand what is the cybersecurity and then the security and then the plant safety. So the concept is here, the safety, we are talking the protection against the environment and then the humans. So that's what we are considering in the safety, utilizing the defensing line, the DIT level, so all the DIT level 1 to the DIT level 5. So that's what we are doing on the safety. We have also the cybersecurity, there is a defensing line. So that's also considered part of the nuclear safety of the power plants. and then the security has also integrated into this defensing line. So here what we are talking here, all these three elements together, we are bringing the nuclear power plant design as a resilience with these three pillars, have one mission, one target. That's we protect let's say, the infrastructure. Now, we have to consider one element here. Any failure in this type of cybersecurity or any incident is occurred, there is also the plant, or let's say the plant operation or plant availability factor, all those ones are impacted. But in the same time, the important elements that the public trust will be going to collapse. So we need to really to careful with this cybersecurity all the time. Any incident that will generate always the public trust. So it will be lost the public trust, which is impacting on the nuclear industry. And the important now, the cybersecurity is not layer on the, let's say, in the after the design, it is integrated. So we call it that the design basis threat elements. It has to be considered part of the design of the facility, nuclear facility. So it's not anymore the silo business. It has to be integrated from the starting till the end. So that's what we need to do with the cybersecurity elements. And when we are really talking the nuclear, we have to talk about the culture, then the humanity elements. So one of the things we have always in a nuclear business, we talk about quite a lot on the nuclear safety culture. And then nowadays we talk also the nuclear security culture. It is almost the same, but there are some sort of balancing issues there. So nuclear safety culture, we talk about more transparent and then very openness and then the very open reaction in immediately. So this type of things are in the nuclear safety culture. We always talk about the transparency. But when we talk about the nuclear security culture, there is some issues that if we have some incident or something has happened, we can't be open, we can't be transparent. We have to be vigilant, we have to be confidential, and then we have to react. But when we have any issue with the nuclear, let's say the normal, any incident or event is occurred, we have to be transparent and immediate action have to be done. So this is a little bit problematic when we are on the reality, when we are in the field of reality to implement these two culture together, because we have to train the people. What's the difference between these two different culture? So this is really important to keep it in mind when we talk about the nuclear security culture, and then the same time we are talking about the nuclear safety culture. So anyway, what we have to conclude here, I need to transfer now to the little bit on the live demo and some, let's say you can see some scenarios with Nathan will going to present it. But remember that what we are talking here, the cyber security or security or nuclear safety, it is we have to be always prioritized in all level of the level. Or, I mean in the management level, even in the workers level, every level, the culture needs to be implemented without jeopardizing any chance, to have any gap on the culture aspect. So we have to really to implement nuclear safety culture and the nuclear security culture together with these aspects. Nathan, I can give you, so you can start.
Thank you, Mansoor. I'd like that stick, please. Thank you very much. So I understand it's the end of the day and it's been death by PowerPoint, so I won't do that to you. I'm going to show you something cool. Now, a lot of things I come across is, I must confess, I'm a bit of a techie nerd. I like to dig deep on what really happened and understand the vulnerability and understand what actually went on. So in my demos, I'll try and show you that. It will be oversimplified, so people that don't understand techie stuff can get it. Now, the first thing I want to talk about is this. It's one of my favorite, most recent hacks. Norwegian dam valve forced open for hours in cyberattack. Let's have a laser. Woo, hours. Now, the way they got in on this was there was a web accessible control panel protected by a weak password. Now, anybody that works in the nuclear industry knows they don't exist. Never. And if they do exist, well, they're so deep in the network that the guys have determined that it could never be hacked. You could never get down there. And during the interview, he said, don't worry about it. An additional 497 litres per second was lost. But he didn't say how long it was open for, and it was 4 hours. So he lost 7 million litres of water. But it was only 497. Now, how does this apply to nuclear? Well, this is just an industrial control system. The valve that got opened was, yes, a water valve, but it could easily be something much more dangerous. Now, I don't know if you've heard of this, but since I'm British, I may as well bring some comical British news. Jaguar Land Rover were compromised recently. I must say, this is speculation. The CVEs displayed here are what we think might have been exploited, and some of the metrics might be off. I'm told I have to say that by the legal team. But let me say what I think happened, and what we've read online. So the two items there, CVE 2025, 31324 and 42999. Now, for those who don't know, a CVE is a publication of a vulnerability, a common vulnerability exposure. Every time you got a Windows update, there's going to be some CVEs getting patched in that. Now, these CVEs were seemingly available on the Land Rover network, and they were left unpatched. Now, this took Land Rover down for 4 weeks. Now, the reason it took them down for 4 weeks is because they had smart factories. They had wonderful, connected, symbiotic smart factories. Every single element was collected and connected to every single site. And I don't just mean on one location, I mean worldwide. Now, if we look at some infographics on this, the impact was £1.9 billion. Cheap. And, but don't worry about it. The UK government bailed them out with my tax money and gave them £1.5 billion to help patch it. Now, on this particular attack, let's say they did compromise that CVE. And how did they move? Well, we must have all heard about IT-OT convergence. You know, we like to pretend that, yeah, well, we spoke to the engineers and they said, don't worry about it, IT is sorting it. And then it stops there. There's not really any mix. The IT guys don't always really understand the OT networks. And the OT guys don't want anything to do with the IT networks. But when you go in and audit them, they're connected, and you always find a network somewhere buried down that goes, oh, well, I don't know how you found that IP because it's air-gapped. Okay. Now, these metrics on here, the anatomy of the Jaguar Land Rover attack, they exploited some CVEs. They gained lateral movement. That's the key one. Now, according to sources, they had no monitoring of throughput on their OT infrastructure. They recognize throughput on their IT infrastructure. So say you download a 4 gigabit file, they'd be like, that's weird, anomaly detection. But the firewalls that existed in the OT infrastructure, they didn't have any anomaly detection. They didn't have throughput detection. They weren't measuring this. While they were in there, these baddies stole, assumably, possibly, stole 350 gigabytes of data. That's research data, schematics, drawings, threat scenarios, all sorts of things. Now, how does that apply to nuclear? Well, it was opportunistic for Jaguar Land Rover. It sounds like somebody saw an opportunity, saw some CVEs, exploited, got in, caused chaos. And they took Land Rover out for 4 weeks. But when we apply this to nuclear, this could be nation-state sponsored. It would more likely be nation-state sponsored. And when it's nation-state, they're smart. We've seen many attacks, many a time, Stuxnet being the most famous, where nation-state will try and compromise the system. Now, more and more we're seeing with our threat intel that people don't really go directly for the companies. They go for the suppliers. Because if you've got one supplier that's making one bearing, or one supplier that maintains one specific system that you're not allowed to touch because it's proprietary, and you pay them to look after it, they keep it safe, and they come in with the laptops that, oh yeah, it's got antivirus, and we've got ISO 27001, don't worry. You know, and then they've got a virtual machine on the laptop that isn't compliant. We see it time and time again. They're the people that are being targeted, the suppliers. And let's say in this instance, a supplier gets compromised, and they get a gateway into the environment. Now, we have seen instances of things like this happening. I can't say where and with who, but these things have happened. And let's say in this scenario, they infiltrate a supplier. Maybe they compromise a CVE. Maybe they implant a backdoor, most commonly known as a RAT, a remote access Trojan, very common. And they could do a shutdown. Now, I promised you I wasn't going to do death by PowerPoint, so I won't. So now I'm going to do some live, it was live once, live demo stuff. And I'm going to show you a very simple OT network being compromised live. Now here we have a very oversimplified concept. We have our bad guy, remote user 2, our supplier that's been compromised. We have their gateway into the network. And let's have a look at realistic commands that they'd run, real attacks that they could run with open source tooling. So they could fire off an Nmap scan, a free tool, simple flags. It could scan through the network on the available IP addresses that it can see. And it could find stuff. These attackers would know, aha, I've recognized that version. I've done a vulnerability test. Sun SSH 1.1.5, that's old. And they could do what any good hacker does. They'd Google it. They'd Google the version, and they'd find a CVE. Now, we asked the head of IT why this internal firewall was unpatched, and he said, don't worry about it. It's on the risk register. So the attacker looks. He finds an exploit. Somebody's made one for him. These exploits are published daily on MSF Exploit. He opens a console. He goes for his attack. He's got one pre-downloaded from GitHub, and it says, hacking into the system like the movies, SQL injecting, cross-site scripting, dumping the database, movie magic. And now the real command. The actual command, the MSF exploit, would run in at the target host and exploit the firewall. Now, we do see things like this. This firewall is now compromised. We are now root, the all powers that can be. And you will always hear somebody say, aha, well, he'd never get in there because it's firewalled off. Well, the firewalls have spilled the beans. So now we're in this firewall. We recognize that we could maybe manipulate the firewall rules, maybe see some more stuff. We previously only had access to the upper layer. So you could say, when you risk assess your supplier's access, what did you find? And you go, well, there's no risk because they can't have access to any other system except for the one they got access to. Okay, well, now they can. So you can run this fancy command, and we'll see we've got some new IP addresses. We didn't know about these networks before. We knew about this one, but these other two, no knowledge whatsoever. So let's run a fancy command. This fancy command flattens the network. No more firewall rules. And we have visibility. We see lower sections of the network, PLCs, engineering workstations, industrial control system cores, operator workstations. Ooh. Ooh, come on, everyone. Ooh. So we have this operator workstation. It's a simple condenser cooling bank. 3 pumps, A, B, and C, for failover. On the right-hand side, we have a switch. This switch will stop you from adjusting it past 12 hours. You can drag it to 11 hours, bing, it'll bounce up to 12. Now, this particular S7 PLC and this software was built with state-of-the-art technology, OWASP configurations, and it had been pen-tested and passed in 1996, and it's been there ever since. So we found this, and we can't directly exploit this application. It's a tough one. But we can capture traffic that goes over the network. And of course, the traffic going over the network, it's not encrypted, is it ever? Well, it's only a PLC. We need to encrypt that. Okay. Has it even got a password on it? No. But don't worry, it's firewalled off. Okay. So our bad guy, what's he going to find? What's he going to look for? He goes down into the network. He spots this thing for the pump house. Exciting 3D graphic. Woo. We'll talk about that later. And he also finds this PLC. It's an S7 PLC. And he sees it's running on this network. He wouldn't see this fancy graphic. I doubt he'd get into this virtual box. But he would have seen traffic flying back and forth to it, and he would have captured it. Now, we're a state-sponsored attacker. We've compromised the upper levels of the network, maybe the IDMZ. We've dropped down into the lower levels of the Purdue model, level 3, 2, 1, arguably nearly 0. And now our primary goal is disruption. Now, we may stay here for years. The British government told us at Cyber UK that we probably have remote access Trojans that are laid dormant in our networks. And they will only be turned on in times of crisis, perhaps a war, perhaps an earthquake, perhaps masqueraded as something else. But they may lay dormant. And the Jaguar Land Rover, they were grabbing everything as fast as they could. But this may be here for years. But we're a bad guy. And our boss has told us, make a mess. So we're going to manipulate that PLC. That PLC's job is controlled by the OWS. And it controls that pump house, those pump banks. And just like Stuxnet, it masquerades the readings to the historian and the readouts. So the engineers in the workplace, everything's fine. No alarms, all the bars are in the green, hunky-dory. But he runs his attack. He's compromised the way this communicates with the S7 PLC, and he hits it with a stress attack. And he manipulates those fields that control how quick it can switch over. He manipulates them. We have a look at the OWS. Now that pump bank can switch every second. Pump banks A, B, B, C, A, B, B, C, A, B, B, C. And I can imagine that's going to cause something bad, something catastrophic. The pump house is on fire. Now, people could argue the safety instrumented system would have spotted this. It was locked down. It was completely segregated by the firewall, but it was segregated once. So, that's my fancy live demo. I hope you didn't have any PowerPoint death from it. And in this concept here, I wanted to make it realistic. I understand that all these presentations, and I experience them as well. I see presentations and I'm like, yeah, but how? How though? This is the how. So handing over to Jonathan, as our partnership is from Airbus Protect to Egis. Thank you very much. Cheers. Swap sides, come on.
So what Nathan has just shown in his previous video is very demonstrative, isn't it? It's very impressive, in fact. So we often think that these kinds of cyber attack only happens to other companies. In reality, everyone is at risk. Indeed, with the growing number of connected devices today, every entity can be impacted, especially the ones that are in the critical domains, such as the energy or nuclear domain, where the consequences can be really severe, not only from a financial point of view, but also in terms of reputation and media exposure. So in fact, that's why it's very important to be compliant with the latest cybersecurity directive in order to ensure that all the safety measures have been properly implemented. So if we do a bit of history, in the European Union, the first cybersecurity directive, NIS 1, so NIS for Network and Information Security, was adopted in 2016 with the aim of raising cybersecurity maturity over all member states, and also to protect the benefit of all the member states. However, the scope of application was too limited, and there were too many differences in application across the member states. Therefore, the European Union decided to draft a second version of the directive NIS. So this is the NIS number 2 that will come into force very, very soon. In fact, we hope by the end of this year. And the purpose is to achieve a common and high level of cybersecurity of all member states. So there will be more than 100,000 entities that will be impacted by this new directive NIS 2. And there will be 18 sectors, and the energy domain will be also impacted. And so please be aware that any entity that will not respect the safety measures in the NIS 2 directive could be fined by the local regulators. And the fines could reach up to 10 million euros or 2% of the annual turnover. So in fact, what we propose, Egis and Airbus Protect, as partners, we have combined our strengths and our expertise in order to offer our client a tailored solution designed to support their compliance effort with the new cybersecurity regulations. Because being compliant with the new cybersecurity requirements and regulation is not only to avoid any financial penalties, but also to protect against potential cyber attacks, and also to avoid having managed a cyber security crisis, such as the one that we've just seen on the video before. So, in fact, Egis and Airbus Protect, we are very competent, and we can offer this compliance with the new cybersecurity directive. Indeed, Egis has all the expertise in the nuclear domain over the entire life cycle of the atom. So from the extraction to the waste management, and also in SMR, in the third power generation, and also is a big player in the R&D projects, such as fusion or fourth power generation reactor. As for Airbus Protect, this is a major player in cybersecurity, which offers a wide variety of service consulting and also a large portfolio of dedicated software, such as, for example, the cyber range that we've just seen before, and that helps emulate cybersecurity crisis. And Airbus Protect also sells a SOC that can help prevent any intrusion on the networks. On top of that, we also do have a lot of lessons learned from other critical domains, such as the defense domain, the rail transportation, and the aviation one. So on very large-scale projects, so we have gained a lot of experience over the past years, in fact. And so our added value is that, based on the fact that we have gained a lot of experience on very large-scale projects over the past years, plus the fact that we do have complementary skills in cybersecurity and also in the nuclear domain, Egis and Airbus Protect, we are therefore able to propose an integrated, innovative approach to be compliant with the latest cybersecurity regulation in the nuclear domain in particular, which is, to be honest, very rare in the market. So concretely, this consists in drafting plenty of deliverables and also providing with dedicated software. So to conclude, in fact, this will being compliant with the latest cybersecurity regulation will help you protect your information system against any potential cyber attack. So thank you for your attention. You want to add something?
I was just going to add, before he closes off, what we've been doing since we've been partnered up is, one of the most common things we see is the engineers engineer great stuff that works. And then they take those designs out and they build them. And the project managers build them. And they build great things that work. And then some cybersecurity guy comes along and goes, yeah, but has it got a 14-character password? No. No, it has not. And then what ends up happening is you have to do defense in depth after, which is tough. You have to end up breaking everything. Since we've been partnered up, we've been designing defense in depth during the engineering phase. So when you're building it, there's extra VLANs, there's extra distributed switches. And then when you've built it and some auditor comes in and goes, aha, but does it have a 14-character password? You can go, yeah, well, no, but we have compensating countermeasures. And according to IEC 60403, our compensating countermeasures bring it up to a security level of 3. Would you like to audit us? And here's how we did it. They go, oh, yeah, okay. So that's my swan song. That's the close of our talk. Are there any questions in the audience that you want to give us? If not, we're going to be in that room over there. Feel free to talk to us. I'm Nathan. I'm Jonathan Mansour. Thank you. Cheers.